Lesson 10, AC Circuit Analysis. Section 10.5, Ho-Thevenin's Theorem. Thevenin's theorem can be applied to AC circuits. This was proven by Dr. Hidetaro Ho. Thus, the AC version is called Ho-Thevenin's theorem. Assume we have an unknown circuit which has L linear elements, M voltage sources, and N current sources. The number of voltage sources and current sources could be 0. The interconnections inside the circuit are enclosed in a black box. If a load impedance ZL is connected to terminals A and B, then VAB and I can be found by applying Ho-Thevenin's theorem. V0 is the open circuit voltage. Z0 is the internal impedance obtained by short-circuiting all voltage sources and opening all current sources. Ho-Thevenin's theorem states that the voltage VAB and the current I in the original circuit are the same as those in the equivalent circuit with the voltage source V0 and the internal impedance Z0. We can find I and VAB from this equivalent circuit. Exercise 10.5.1. Derive VAB and I as functions of Z1, Z2, ZL and V, by applying Ho-Thevenin's theorem. The answers to exercise 10.5.1. The open circuit voltage V0 is given by this equation. The internal impedance Z0 is expressed by this equation. Then VAB is obtained as shown in this equation. Exercise 10.5.2. This is your homework. Pause the video, and write down the answers. Derive the voltage VAB between node A and B. Experiment 10.5. Pause the video, and follow the instructions. Measure the open circuit voltage V0, and derive the internal resistance R0. Confirm that VAB EQ matches VAB. The answers to experiment 10.5. These are the measured waveforms of the source voltage V and the voltage across nodes A and B, VAB, in the original circuit. The effective value VABE was 1.19 volts, and the phase shift psi AB was negative 32.0 degrees. These are the measured waveforms of the source voltage V and the voltage V0 in the open circuit. V0E was 1.41 volts, and the internal resistance R0 was 0.5 kilo ohms. These are the measured waveforms of V0 and VAB EQ in the equivalent circuit. VAB EQ was 1.18 volts, and psi AB EQ was negative 32.0 degrees. These values matched the values in the original circuit well. Exercise 10.5.3. Pause the video, and derive this equation by applying Ho-Thevenin's theorem. The answer to exercise 10.5.3. V0 is obtained by removing Z5. Z0 is the internal impedance as seen from the nodes A and B, when the source voltage V is short-circuited. Using Ho-Thevenin's theorem, I5 flowing through Z0 and Z5, is obtained. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.